Hello everyone. In this video we are going to talk about the Prusa Original I3 MK3S hardware. In one of my previous videos you saw me talking about the slicer software, and I'll try to cover every aspect of it that I knew. So in this video I'm going to familiarize you with the hardware of Prusa Original i3, and in the next video I'm going to talk about the troubleshooting and the failures that can happen during a print. So this is the Prusa Original that you can see in this picture, or you can see it here from my webcam. Now as I go forward and explain different parts of the hardware, I'm going to move my camera very close to the printer so you can see it in a lot better resolution. So the printer has 4 axes, X, Y, Z, and E, and it has also several stepper motors. So it has 2 for the vertical axis or Y axis, right? So if I want to mark the axis down for you, so the y-axis is this axis that goes forward and backward, so this axis basically, right? This is your y-axis. It goes forward and backward. Your z-axis is the one that goes up and down. And you have these guides here, this one, and this one. And you have these screws, vertical, that rotate and lift the whole system for you, correct? So these guys attach to the stepper motors. Actually, let me make sure. This is your screw here, green, and this one. And then these 2 in red are your guides, which you really try to keep in good condition and keep them upright. If they are bent, the Z motion is not going to be any good. Then you of course has the X-axis, and X-axis is basically is possible through this stepper motor that you see here. So that is this axis going to left and right. That's your X motion. And when they say E, E is not really a motion that you see for the hot end assembly. This whole thing here is your hot end assembly. E means the fact that the wire, the spool, is being pulled into the stepper motor, melted, and then laid down on the print bed. So the E axis here is basically the extrusion axis. So that's the name of the axis, and the E axis has 1 stepper motor, the X 1, the Y 1, Z has 2 stepper motors. So in general you have 5 stepper motors. Your Y is down here on the back. So 5 stepper motors, 4 axes. And when we go to the user interface here, or the monitor, there are commands that you can separately and manually move each and every one of these axes by turning this knob. Okay, so let me show you those, and then I come back and talk about the what's inside the hot end, correct? So let's go ahead and move the camera forward. Okay, so here on user interface, if I click on this knob, I have the info screen, which when I start the print shows me the time left and the percentage of progress and temperatures and everything. Then I have, of course, a print from a SD card. When there is a SD card, which here there is, actually, if you look here on the side, this is your SD card here, right? So you can just put it in the slide on the side, and then it reads any file that is on your SD card, and you can go there in that location I just showed you choose a file and start the print, right? So here you see there are these files here on my SD card, and I can print any of them that I want. Here is load and unload filament. We talk about it, but what I told you is first to move the axis. So for that, you go under setting, go under move axis, and here you can choose which axis, X, Y, Z, or the extruder, right? So for example, if I want to move this bed a little bit backward or forward, right? Let me also move my camera backward. Then all I need is to click on the Y axis move, and then all I need is to turn the knob. So once I turn the knob, you see that, as you can see, this guy is moving forward or backward, right? As you can see here. And similarly, I can go ahead and move the whole system up and down. So let me show you that as well here on the side. So here I have chosen the Z-axis, and now as you can see, it is going up and down. This screw system here is used, and the guide shafts are used on both sides to keep it vertical. And then similarly, I can do the X-axis. So here is the X-axis, and now as you can see, my hot end moves to the left and to the right, as you can see here. And then I can have the E-axis, where I can pull the filament in and out really. So this is moving the axis. Okay, the other thing that I mentioned I want to show you is the hot end. So the hot end of the Prusa is a big assembly. There are so many parts in it. And so I just want to see the important parts of this assembly. So the major thing inside the hot end is this basically several 5 or 6 components that are responsible for melting the plastic and putting it on the print bed. Although above these we have the gear, the main gear for basically the E-axis, as well as the idler gear. So there are a couple of gears above these that when those 2 gears rotate, they pull in the plastic from the top of the hot end assembly, right? And they feed this system here through the stepper motor that you can see here, right? So here you can see this is the stepper motor. It is going to turn one of the gears that is right above this system, and then there is the other gear, the one that is used to help with the tension, right? So this plastic, the filament, is going to come through between these 2 gears, right? This, correct? So this is your filament coming through. And as I said, one of them is driven by the motor, by the stepper motor that you can see there. Good. So when this plastic come in, they come in through what we call a PTFE, or a Bowden tube, or some people might just call it a friction tube. So this tube is here. It sticks out of this assembly, as you can see better here, right? That's this part here. And what it does, it helps that filament, that plastic, to basically, let me see if I can move this a little bit out of the way for you, because it is overlapping some of my writings. There we go. So it helps that plastic to be protected, the filament to be protected from being bent before getting inside the melting system, right? And it's kind of protecting it. So that's the Bowden tube or the PTFE tube. When it comes in, then the goal is ultimately the plastic goes into this guy. This is your heat block. And attached to this heat block, you have the heating element with the wires. So there's two red wires, and that one is the heating element, the ceramic component that brings the heat and heat up this area here. This area is very, very hot. This heat block and the hot end, they are very hot, heated through the electricity coming through the heat element. And you also have the thermistor, this guy here, which senses the temperature of the heat block, gives it back to the temperature PID controller of the system, so it can control this temperature around the desired temperature. So you have the temperature, the actuator, the sensor basically for temperature. You have this heating block, which is made of aluminum. Then you have the heat sink, which are these fins here. And the goal of them is to help with the heat transfer of the system and avoiding this area to be super, super hot. So these heat sinks, the goal of them is to pass the heat to the air through convection and basically keep the overall system in a good temperature. And then between this heat sink and the heat block, we have this guy here, which is called the heat break. And the goal of heat break is to separate really the area that is kind of super hot. So this area is really hot, and this area here is not so hot. So the goal of this element that is threaded into both the heat sink and the heat block, this element is heat break, is to separate these two guys. And this guy is typically made of stainless steel because the heat conduction of that is not as high as aluminum or the brass, which is typically used for the hot end or for the nozzle, you might call. We typically call this guy the nozzle, not really the hot end. Nozzle is the element that is used to reshape the plastic that is coming in into the diameter that is of interest. So typically this wire that goes in, as you know, this is 1.75 mil in diameter, the standard, but the diameter of this nozzle here, phi, is typically for a standard one is like 0.4 mil. So here you are reducing the size of the filament being laid on the print bed and allowing for a better XY resolution. There are other diameters of the nozzle. There are smaller ones that are bigger than 0.4, and there are different types of plastics too, but these two numbers, 0.4 and 1.75 mil, are kind of standard. Right? So I told you about the heat break, the heat block, the heat sink. I told you about the nozzle. This is made of brass, and typically this is good for regular filament. If your filament that comes in is really different, it's a specialized filament, like it has particles in it, wood particle, metal particle, carbon fiber, or anything like that, then this brass nozzle is not going to work for them. It is going to be clogged very soon and very fast. So for those applications, what we need, let's see if I have that picture of it here. So for those applications, what we need is this guy, which is hardened nozzle, and this guy is made of steel. This is a specialized type of nozzle that you need, and you can also buy this guy from either Prusa or from Amazon, and this guy is designed for special type of plastic. Okay, so here is your hardened nozzle. Let me see if I can put it in the right location. Hopefully, if not, that's okay. So I also told you about the thermistor and the heat element, which are these two guys over here. This one and also this one. Okay, so now most of these elements here you can buy also from Amazon, because if you want to buy, Prusa does not sell its printers on Amazon or even the boards, but the side elements, the paraphernalia really of your printer, you can buy on Amazon, because the shipping cost from Czech Republic is like $50. So if you want just like a nozzle, or if you want a heat block or a heat sink that are like $10 or below or something like that, you're not going to pay $50 to be shipped from Czech Republic. And on Amazon, if you go, you can find these specific elements. So in the video description, I'm going to add all of these purchase links on Amazon. I use them all myself for my printer. I had to buy several times these elements because I really could manage to break each and every one of these elements when I was learning. And I really know these links are selling genuine parts that would definitely work with your Prusa, right? So if you want your print bed and your hot end print fan and hot end fan, right? You can buy it. If you want your IR sensor, you can buy it. If you want your heat element, you can buy it, right? This is the brass nozzle. I'll talk about this in a second. If you want the heat break, if you want your heat block, if you want your heat sink, these are all there. I add also a link for Thermistor for you. And then this is one of the things that I absolutely recommend you add to the bottom of your heat block and to the nozzle. And these are called socks, right? Like the socks we wear. And these are amazing. So what they do, they cover around your heat block, and only they allow a small hole for the tip of the nozzle to come out, and they will protect your end of your whole hot end assembly from plastics or molten plastic to be wrapped around them, and then you get a big ball of molten plastic wrapped around your nozzle, right? So because many times the plastic that you're trying to print and lay on the bed, it happens that it doesn't stick to the bed well, so instead it goes back and melts itself, that plastic, onto the heat block, because the heat block is very hot. So if the plastic doesn't stick well to the print bed, you're going to see a big fluff like this that very fast is going to cover your nozzle, and then your print is going to stop. It is going to crash with the bed, and this happens a lot. So what that mechanism does, what we call the hot end or the heat break socks does, it covers all through this area for you. And it only has this small hole that this plastic can come out. And if the plastic doesn't attach, then it tries to go back and again attaches itself to the heat block, but this time it is going to be attached to the sock. But the good thing about the sock is the sock does not get as hot as the heat block, and it doesn't have good adhesion. So the plastic by no means can attach itself, the hot plastic, to the sock, and it has to fall back onto the print bed. So you will never get that big fluff around your tip of the nozzle, and you're not going to have that mode of failure so fast. So I absolutely recommend, this is another thing, invest a few dollars in one of them or three of them in these we call the hot end socks, and they are extremely good things to add to your Prusa printer. So as I said, I'm going to add the link for that, and I would also add the link for you for the Aquanet, as I said. This is what will help your print to be stick to the metal bed very well. Do not use a glue stick for Prusa, by no means. The other two things that we just mentioned are a print fan and hot end fan. And for Prusa, this here on the side, this fan is your hot end fan. And this guy here on the front, this might be called side fan also. This front fan is what passes the air through this fan shroud right below the hot end, and that's where the plastic is being printed. So this is your, we might call it layer fan or print fan, and this is your side fan. The other things that I mentioned is the idler tension bolt, which is this bolt right here, as you can see, this one here. Let me use my finger. That guy, and that one should be almost flush with the plastic surface it is on or slightly below. Do not over tighten that bolt and push it all the way in, because that one basically determines the amount of closeness of the idler gear to the pulling gear. And if they are too close, then you have a very, very strong grip of the gears on the plastic that is being pulled in, and that is going to ruin the surface of the plastic. You might get jams inside the hot end, and you might get also broken plastic, broken filament left into the hot end, which is another reason the hot end gets clogged. Also, if it's too loose and if it's coming out of the surface, so it's sticking out, then this idler gear and the main gear cannot easily pull this plastic in, and that causes the plastic coming out of the hot end to not be proportional to the amount of the flow rate that you expect. So you will have under extrusion. So that's another element you need to know. Then each one of these stepper motors, as you know, they are working by a basically we call it a timing belt. So you can see the timing belt here. You can see the timing belt for the x-axis here. That one was for y-axis. The z-axis does not have a timing belt. The z-axis has this screw system, right? And the e-axis also is, or the extruder axis does work through those two gears. So two of your axes, which are basically x and y, do work through these belts. And in order for those two axes to work properly, you need to have enough of tension in these belts, okay? If they are just sagging and falling on the top of each other, that means the tension is not enough. Also, if they are almost about to be broken apart because the tension is increasingly high, that causes another problem. But if you bring your finger and try to touch it, you have to apply a little bit force in order to be able to make these two belts basically touch each other. So, but you can also check it in the user interface. So here, if I go to user interface, one of the things that you can do is to check the tension in the belt. So you click here, and then you go down to, again, calibration this time, and then once you go down, one of the options, as you can see, says belt test, and when you do that, then it moves each and every one of the axes that are working with belt, and in this case x and y, and you see it does move x-axis through two of the endpoints of it, does the same thing for the y-axis. And then based on the amount of acceleration that it observes, it gives you the estimated amount of tension. For many printers, this tension test is typically completely done experimentally, and it's not like this. As you can see here, it gives you a number. and it says, hey, you're checking, if I'm checking on your X and Y axis, you saw the numbers were very close to the ideal case. And if I want, I can make them a little bit, basically add to the tension of them, but you saw that the numbers were very close to the ideal expected number. So in this case, I'm okay about the tension in the belts. One other thing, let me show you specifically for X-axis is this bolt here. This bolt, if you basically tighten it a little bit further, that allows a little bit further tension in the X-axis. Okay, so that bolt, that Allen bolt there, can help you increase the tension or release the tension on the belts of the X-axis. Okay, another thing that is extremely important is calibration, right? You want to make sure your axes are calibrated, X, Y, and Z. And to do that, you again click here on the knob and go down to calibration. And here you have a first layer calibration, which is a separate topic we're going to talk about, but we have calibrate X, Y, Z if you want to calibrate all three of them, or it can just calibrate Z. Z is the most important one between X, Y, and Z, but definitely X and Y are very important too. So it can calibrate Z, and what it does when you click on it, it basically first homes the hot end right here. And then now it is going to says, hey, make sure the nozzle is clean. And when you say okay, it is going to measure 9 points predetermined on the surface of the bed and measures the relative height between your IR sensor and the metal bed. And if these distances are all good, then it is fine. Otherwise, it is trying to consider the unequal amount of offsets on these 9 points when it tries to basically do the printing. Again, for many of the printers in the market, this Z leveling is done completely manually. You typically have a few knobs below the bed at, let's say, 4 points, 4 corners or so. And then by rotating them clockwise or counterclockwise, you can raise those points a little bit up or down. So here it is done through software. And you see here it checked 9 points, but if you want a 3x3 mesh, basically, if you want, you can go ahead here. And then if you go down under setting, and go down under the mesh bed leveling here. See, it says mesh bed leveling. If you go there, instead of mesh 3x3, you can change it to what? Mesh 7x7. So here it is using more points basically to do the Z calibration, and that allows a little bit nicer, basically, or more accurate, to be exact, more accurate Z calibration. Okay, one of the other thing is definitely load and unload. So you click here, and then here you have load and unload. And let's say here I want to unload the plastic, and they have different temperatures. So PLA 215, I click on it, and the temperature in Prusa goes up very fast. That's one of the best features of this printer, is you don't have to wait a few minutes for it to reach 215 Fahrenheit. It just flies, literally. It's very good. The hot end design of it is amazing. So once it reaches around 205, 210, it beeps. Let's see. Here we go. And now when you just push the knob, it is going to kick the plastic out. So let's go ahead and do it. And you see, there we go. So now, if you look at the tip of this plastic, actually it's not too bad, but many times when this plastic comes out, it's not super clean and nice. Or when you get a new spool and you want to basically put it into your printer, it is not really super clean and nice. So what I recommend always is, if there are some small portions of the plastic left on the tip of it, you always make sure, bring one of these cutters, cut the filament, and if you want to be easily, if you want it to easily be inserted into the hole on the top of the hot end, I recommend you cut the tip of it at angle like this and kind of make it like a wedge or like a spear or something, right? If you do it like this, as you can see, it is now quite sharp. Maybe my camera can take it. And now when you pull it in, it is going to be a lot easier for it to go through the two gears, right? And again, all you need to do here is go ahead and click on the load. One of the things that Prusa does, if you unload, it doesn't let the temperature go. It tries to keep the temperature because it knows you probably want to replace the filament, right? If you don't, after some time, then it disables the heaters and let the temperature drop back to normal. But here, you see, it is keeping the temperature for you at 215, at which you can also load PLA, right? So if you say now PLA load, and now the gears are working, all you need is to gently pass this through the gears, and now it is being slightly pulled in. Once the plastic starts to come from the bottom here, and it is the color that you want, you can say okay. If it is not, when it asks you, is that the true color, you can say no and let it extrude more plastic here, right? So always make sure that enough of plastic is coming out and it is the color that it should be. And once you're happy, of course, you say yes, and now your plastic is extruded. So what else do we need to talk about? One of the other things is changing the temperature, flow rate, fan speed, print speed, and everything during a print. So let's say here, I want to start a print, right? So I say print from the SD card, and then let's say I go ahead and I print something, correct? So let's say I print some simple parts. Let me just go with something, maybe this part here. Okay, so I start it. It definitely gives me the amount of time that it needs, right? As you can see here, it is 27 minutes. And the temperature for the bed and the hot end are good, 60 and 215. It shows you how much of the work is done. Right now, 0. It is just doing calibration on 9 points, right? And you always make sure your print bed is clean. If the print does not stick, you definitely always have to use the hairspray. I absolutely do not recommend you use a glue stick for the metal bed. You are always recommended to use this Aquanet hairspray. This one, that is your best friend when you want to have good bed adhesion. These are very cheap. You can find them in Walmart. And the important thing is you make sure you just spray a very, very small amount or a very thin mist. You do not want to soak the bed. You should not have ponds of that spray on the print bed. So now the print has started. As you can see, 2% is done, 26 minutes is left, and so on, right? Now, if I click here, this is your info screen. If I click here, I can do live adjust if I want to. Now, if it's your real print, you don't want to do that. You want to do it on a practice print or something. And you can pause the print definitely. You can stop the print, right? You can look at the statistics of the print and anything. If there is any fail statistics from previous prints, you can see that here. And if you want to change any parameter of the print, you go under Tune. And now, let's say here, instead of the 100% speed, you might want to speed up the print. So you can bump it up to, let's say, 150%, right? Now the print is going to be a lot faster. If you go to print screen, you see instead of 20 minutes, now the estimated time is about 16 or 26 minutes. It's now about 16 minutes. Now, of course, this in general is not really a super good idea to just expedite the prints by doing what I just did physically and manually, because there is always a good chance of losing your quality of the print, failing prints, and worse than that, the filament being clogged, okay? And it happens quite a bit. So the ideal design for the PLA, the print speed, the temperature, and everything else, we call it the print profile, is determined by the factories. So you don't really want to overwrite that like I did, okay? But if you want to, I just showed you, or let's say here you want to bump up the temperature of the nozzle. Why? Let's say you bought a PLA and this PLA needs a custom temperature. Instead of 210, it might need like 220 because like it's tough PLA or it has particles in it. Now, of course, you can do all of that in the software before you even come here. But if you forgot, here you can just bump up the temperature. You can bump up the temperature of the bed. You can change the fan speed. You can change the flow rate. Here is 95%, but if you want, you can go more than 95%. If you want, you can click on change filament. What is this? It is going to pause the print, wait for you to change the filament, and once you click on it, it will resume the print with the new color. And that is basically what you do if you want to print different layers with different colors, right? I mentioned that in the software. I showed you with those number plates that I made, that I printed, let's say, the bottom of it in orange and then the top of it, which were numbers, in white. So, but when you do that in the software, it does this automatically. You don't need to come here and wait when it goes to the layer of interest, then you say change filament. It does that automatically. It adds that to your G code, right? So there are a bunch of things that, as I said, you can do here. Here, you can see other things. You can check the fans on. You can make sure the fan checks are on. The crash determination is on. The sound, if you want, you see. And this is really not the sound of your printer. This is the sound of alarms. So you saw, for example, when the temperature was reached, I got a big beep and it was loud. You can make it silent, then you would never hear that beep. So you have to be very present. Or you can make it assist or loud. I would rather it give me a big beep when it wants me to do something. You can change the brightness and so on and so forth, right? So here are the bunch of things that you can do, right, during a print. And let's say here I want to stop the print because I want to show you some other things. So I just say stop, yes, and the print is aborted, right? Okay, let me mention also this return button. This one will return everything to the top level. And basically, if you are during a print, when you click on that return, you are literally canceling your print. So make sure you do not click on that return unless you really know what you're doing. It's not like a back button or something. So here we click, and the other things I want to mention for you is let me make the focus right. There we go. Preheat is just to put it at the temperature that is right for your application. I barely use that because once I start my print, it is going to heat up to whatever I want. So I barely use preheat. I guess I showed you most of the stuff under the setting. By the way, in setting, not only you can move the axis when a print is not going, you can also change the temperature of the nozzle or bed or the speed or anything when there is no print going on. So without any print going on, you can just raise the bed temperature or nozzle temperature or make a fan rotate or anything for that matter, okay? So there are a bunch of important things that are under the setting. You can do temperature calibration, right? There are so many other things you can do. Live adjust, I'll show you that. Change the language, sort, sound, brightness, and so on. But what I wanted to show you is mostly under calibration. So there is a calibration wizard that starts from scratch. This is like the first time that you buy the hardware and you want to set it up. The wizard comes up and it checks each and every one of the hardwares. So if you want to check from scratch each and every one of parts of your hardware, you can do the wizard. Or if you're all set, you definitely need to do first layer calibration. If the offset in the first layer calibration is wrong, you are not going to get any good print. There is auto home here. Belt test I did for you. Self test does a little bit more than that. It's kind of similar to that wizard, does everything. Mesh bed leveling I told you. PID calibration, reset, temperature calibration, and so on. So what is really important, as I told you, is the first layer calibration. And although this one needs a video of its own, but let me just show you. So when you start this, it starts from a number that you already set, or if it's your first time, it starts from 0 offset, right? And you say continue. The filament is loaded. It is PLA. And then it allows you to start the print. And what's so important about this first layer? Let me show you when it starts. Okay, so here I have started the first layer adjustment. And as you can see, the amount of offset for me is negative 0.2. And here I changed the color of the filament for you to purple so you can better see the print. The important thing here is what it does right now is it is really printing a zigzag first, and then it is going to print that zigzag basically in a kind of very close distance to each other. So I let it do its job, and then I tell you based on the appearance of the spool on the bed whether the distance is good or not, and what is it that you should do based on the appearance of this first layer calibration. So I just let it do its job, but if I want, at the same time that it is printing, I can go ahead and what? As you can see, I can change the offset to whatever number that I think is the correct offset. But how? I need to have a base for my judgment, okay? It's not just like, yeah, I just try bigger or smaller numbers and do a ton of trial and error until I find out which one is going to give me good bed adhesion and so on. So here that it is printed, let me take the bed off and show you. Specifically this area here where they are printed very close to each other. This is the area that tells you most of the things. And if you look at this, as you can see, the layers are printed very, very nicely right next to each other, okay? If the offset is basically is what? It's bigger than this. So you need to bring down the hot end and make it closer to the bed. If the offset is bigger than this, like instead of negative 0.2 is like negative 0.1 or positive 0.1 or anything, then you're going to see basically some bulbs here, some bulges of plastic, because they are kind of being dropped on the surface instead of being laid out on the surface gently and smoothly. And if I bring it very close, now you're going to start some waves on the pattern. And definitely you are not going to see the filaments, the layers, to be this nicely attached to each other without any gap between them, without any drop of the plastic, without any waves in the plastic or anything. So when you get it flat and nice like this,
and there is no gap between adjacent layers, that is a good print. And also you should be able to peel it off, but the peel off also does not need to be, the plastic should not be pushed so hard to the print bed that you have to really wrestle with it to take it off the bed, or it should not be such a very weak connection that if I just touch it like this, the plastic comes off. If you just simply touch it without pushing your nail underneath the part, and it just comes off, so there is no real good connection, that is an indication that your hot end distance is more than what it should be from the bed. On the other hand, if this plastic is kind of like embedded into the bed, right? It's pushed so hard into the bed that now you have a very hard time even with your nail to get this plastic off. That means your hot end is too close. So if it's just like a good connection like here, but still, if I put my nail underneath it, and I don't have a big nail here, but you see, if I can get it off like this, that is some good solid connection. Otherwise, your print bed is definitely closer to or further away to the hot end than the standard expected number. So hopefully I could have covered some very basics about the components of the hardware, the name, the terminology of the axes, and so on, the setting, the calibration, load and unload, and so on. As I said, in my next video, I'm going to talk about different modes of failure, right? And what is it that you can do about them to fix them or avoid further failures in the future. So thank you so much for your attention, and I will see you in my next video.